Thanks for joining us today for this webinar entitled Realistic Simulation for Optimized Packaging. And today we're going to explore flexible packaging simulation. And we're lucky to have with us again Pierre Paliughi. He's a senior technical manager at Dassault Systèmes. And Pierre has 15 years of experience in technical development across R&D, tech sales, and solution design, and experience with SAP and Siebel before joining Dassault Systèmes. My name is Brian Carboni. I'll be your host today. I am the industry marketing leader for the CPG and retail industry vertical at Dassault Systèmes. I have 20 years background in the CPG industry across marketing, category management, and sales roles with companies like the Gillette Company, Procter & Gamble, and Helen of Troy prior to Dassault Systèmes. For an overview today, we'll talk about the trends and challenges facing the CPG industry and packaging, and why simulation is needed more than ever in this day and age. And then Pierre will take us through a technical demonstration of our simulation capabilities. Now, for trends in the CPG industry, consumers today are continually reevaluating and changing the way that they view, they interact with, and discard packaging. And some of the key trends that have emerged are sustainability. Now, sustainability is now part of the perception and identity of a brand. It has become that important to consumers and retailers alike. And in terms of convenience, with today's busy lifestyles of consumers, they are reverting back to smaller, lighter, and more easily disposable packaging to fit those busy lifestyles. And in terms of cost-effective shopping, people obviously don't want to pay more than they have to, but this trend towards smaller, lighter packages has made consumers more money conscious in their buying decisions. So optimizing the cost on packaging is critical as a response. And there are some pretty significant challenges in the CPG industry. As customers, and in this case, customers mean retailers, as customers and consumers want more variety, they want more product innovation, they want high quality at a low price, and they want products to be sustainable. That's putting pressure back on the packaging manufacturer as they need to think about the energy cost, the material cost of their packages, and what type of environmental impact will those materials and those packages have. The real issue here, as CPG brand manufacturers or packaging suppliers look at a package design, it's an optimization problem. And in order to get that perfect package, like the chart says, you want to be here in this sweet spot. You want the minimal amount of material used, yet also have that package be reliable enough to stand up in manufacturing, in transport, and to have a very healthy and sturdy life on the shelf. Now, if you don't use enough material, yes, you'll have lower material costs, but the damage costs may outweigh that in the long run. And if you have too much material, obviously your materials costs go up, but you may also price yourself out of the market, just remembering back to the consumer trend of more cost-effective shopping. So the real issue we need to ask is, how do you get to that perfect package as quickly as possible? Now, traditionally, the model looks like this. You design packaging, you build a prototype, you test that prototype, and you understand its strengths and weaknesses, and you repeat the process with an updated design. And you do this continually until you feel you've put your best foot forward in terms of packaging. Now, there's a couple problems with this method. One, it's time consuming, and with competition, global competition on the rise, speed to market is more critical than ever. And this traditional method could be slowing your enterprise down. It's also costly, not just in terms of the cost of building prototypes and testing them, but the cost to have all these engineers working on a project for a longer period of time and perhaps not on other innovative projects. And how do you know that package is optimized? Now, simulation comes with some solutions in these areas. With simulation, you can fake it before you make it. Simulation allows you to evaluate multiple designs up front in the design process. you can consider more design alternatives earlier. It enables non-simulation experts like me to prove out their designs through access to streamlined processes. And you can capture, share, and reuse simulation and analysis data throughout your company, so on multiple brands. Now, our solution is called the Perfect Package Industry Solution Experience. It's a platform-based model, and with our simulation tools, there are multiple benefits, including you can reduce your package weight to decrease your materials costs and drive lower CO2 emissions. So think sustainability and lower costs. You can accelerate your design time by removing the need for physical prototyping and testing, so that cycle you're in of constantly designing, building, and testing, you can streamline that. And you can optimize your package design to increase shelf life and really delight that consumer. And we have simulation solutions for several different types of packaging, including flexible, rigid plastic, and cardboard. And today we're going to discuss simulation for flexible packaging. And I'll turn it over to Pierre for a technical demonstration.
Hello everyone, so in this video I will show you the complete workflow to produce a flexible pouch. So the basic idea is to start with a 2D design of the pouch, like in the real manufacturing process, and with a CATIA application named Generative Shape Design, you will be able to create the 2D aspect of the pouch. So what we need to create and to proceed to a flexible pouch creation is to create a small cavity inside. So what the designer is doing here, he creates an assembly with 3 parts and with a small cavity. Then what we will do is we will project this 2D model on a drawing in order to be able to create the artwork of the pouch. So here I export my model as a DXF, and then I'm able to work and to create my artwork on this 2D design. So as I created my 2D design, I want to see how it will be when it will be filled by a liquid or by some product. So what I will do, I will define an FEA simulation, and I will reuse all the parts of my assembly. Then I will mesh each part with a precise mesh in order to capture all the ribs of the pouch, and then I will define the cap as rigid. I will define also the tie connection, so what will be the face that will be fixed together, and then I define my cavity. So here my cavity has the properties of the liquid and will be inflated with a realistic shape. Then I will fix some degree of freedom, so for example I will fix the top of the pouch in order to be not able to move, and then I will also define a pressure on my cavity. So in that way the cavity will expand and fill the pouch in order to have the realistic behavior. So this simulation is very fast. It's about 1 or 2 minutes and allow you to have a quick result of the flexible pouch. So in that way you're able to have a realistic shape based on simulation. In this simulation, so it's the higher level, so it's more for an expert of simulation, I will realize the real process, the real manufacturing process of the pouch. So we define a ground and we define also a cylinder with the properties of a liquid, but it will be SPH particles, so the cylinder will be split in several points that will correspond to particles, and this particle will have the same behavior as a liquid. So here I'm proceeding to an explicit step which contains 3 levels. So the first one is I fill with the liquid, then on the second step I will fix the top, so by contact. So here my liquid is inside my pouch with a certain speed and a certain density, and then in the second step I will fix together the two top part of my assembly, and then still corresponding to the manufacturing process I will drop the pouch on the ground in order to be sure that the pouch is stable, or to be sure that the liquid will not be outside of the pouch. So here it's a simulation for expert, not as the first one, which will be more for a designer. Then when I finished all my simulation, I'm able to export the right exterior shape I need to create my high rendering aspect. So here I exported my result, and what I have is I'm able to see the first shape, the 2D shape, and the 3D shape based on simulation. So when I have exported this shape, I need to recreate a surface based on this shape. So it's very simple. Some tools are able to clean the mesh, to clean the external surface we exported, and to recreate on it a surface, and then to apply a UV mapping. So you will see how it's simple. I select my face, I select all the detail of the recreation, and I'm able to see directly my 3D pouch based on the simulation result. So then when I have done this, I'm able to use the UV mapping tools that will create a UV parametrization on the surface, and then to remap the first artwork I did with the 2D pouch on the 3D pouch. So you will have a realistic result with the right artwork based on the 2D dimension, and you will be able to see directly how it will react with the realistic shape, and if the texts are well placed, if the shape look good or not. So here in the simulation I'm applying all my materials, and then I'm able to do some very high rendering videos for marketing or for customer.
And to recap, please visit www.3ds.com/perfect-package. On our site, you can get more information on our solutions. You can download free case studies, including WestRock, Amcor, Saint-Gobain, and PTI. And you'll have access to other white papers and ebooks as reference materials. We'd like to thank you, and we hope we talk to you soon.